Hello and welcome. So today I'm back to my series on introductory financial modeling, and we're going to be looking at precise debt modeling. So this week I'm going to be looking at questions from the ModelOff competition in 2014, round one. So today we've got kind of the technical question, or the more technical question from the round, which is precise debt modeling. And then we've got one about dealing with data and one that's just fun, modeling a snakes and ladders game to figure out how much advantage the first player has. So let me give you a quick introduction to this question, and then I'll talk about some of the sort of decisions around how I'm going to present it, and then I'll walk through the solution. So the idea is you work at a bank, you're forecasting a loan, and basically the idea is you want to be more precise than a usual, so the typical kind of mortgage payment functions in Excel, the PMT, IPMT, PPMT, if you've ever used those, are based on, everything is exactly, 1 month, every month is, we pretend that every month is as long as every other, and the interest in any 1 month is the same as any other. But sometimes you have to deal with a more precise scenario. So in this case, you can you have different payment dates on different days of the month. So let's say if you draw your loan down, like the first one here, you draw it down on the 19th of January. So then your payment would be due on the 19th of January every month. But it can't be on the 19th of January every month because it can't be on a weekend, and it can't be on a holiday. So your payment has to fall on a business day, and that means that the number of days within any, between any pair of payments could be, 28, 29, 30, 31, 32, and the interest is calculated based on the exact number of days. And so it just kind of makes everything a little bit more complicated and gives us some fun to work with around work days. So the idea is loan payments are made monthly on the actual payment date, with the first payment 1 month after the drawdown. So there's a regular payment date, and that is the same day of the month as the loan drawdown. So if the loan is drawn down on the 8th, then the regular payment date is the 8th of every month. And then there's some rules for calculating the actual payment date from that. So first condition is if the regular payment date is not a business day, meaning it's either a weekend or we've got a list of holidays over the relevant period here, then you go to the next business day. Except, and it tells you, for the first, basically for the first loan, the first loan is drawn down on the 19th of January, so you're never going to have weekends and holidays taking you from the 19th of the month all the way into the next month. But you could have from the 30th of the month all the way into the next month. So, except if that next business day takes you into a new calendar month. So condition 2, if that gets you into a new calendar month, then the actual payment date should be the last business day of the calendar month. So before the regular payment date. And if the regular payment date is the 29th, 30th, or 31st of the month, then in a month with fewer days, i.e., if it's the 31st of a month with 30 days, or any of these dates of a February with only 28 or 29 days, then the actual payment date is the last business day of the calendar month. So a little bit complicated, but nothing too crazy. Monthly payment amount should be the same amount for each period and include interest and principal. The interest is calculated on actual over 365 basis based on the number of days between successive actual payment dates. And there's basically a warning here saying your manager advises you you can't use PMT, PPMT, or IPMT because they're based on equal months. So it suggests here to use Excel goal seek. I'm going to show you a way that you might not need to do that. So the interesting thing in presenting a solution to this one is I could whip up a solution to this in about 10 minutes by pulling a couple of rabbits out of hats, which is to say, there's a nifty function that you probably don't know, that I didn't know when I was doing this, that lets you go to the next workday or the previous workday in Excel based on weekends and a set number of holidays and everything. And if you have that, this question is quite simple. So I was a little torn about, do I pull the rabbit out of the hat and say, ta-da, here's a super short solution. I think what I'm going to do, back in 2014 when this question first came out, if you didn't do it the rabbit out of a hat way, it was quite convoluted. But actually with modern functions, with things like sequence and filter, you can do a reasonably elegant approach to this from first principles. So I'm going to show that first, then I'm going to show the rabbit out of the hat, with the workday function. And then likewise here, I'm going to show you how to get the answer here with goal seek, and then I'm also going to show you a jazzy way to work it out exactly. Which is, if you needed to kind of flex these assumptions or to model it for 100 different loans in a portfolio or something like that, would be much better than using GoalSeek, where you have to tweak it manually every time. All right, so that's enough preamble. Let's dive on in. So we've got basically two loans we need to model. One is for $250,000, 72 months, drawn on the 19th of January 2015, and 5.2% interest rate, and the other is 100,000, 48 months, 30th of June, 7%. So I'm just going to set up a new tab for the model, and where are we going to start? Let's start with, well, first of all, I'm going to just bring loan one over here so I can just work with it more directly. That'll be a little easier to do. So the first thing I'm going to do is I'll just have a counter for period number and sequence 32. Oh, sorry, that's the other thing to mention here is, the setup tells you that the model should allow for up to 72 months in the model. Now, when you're only modeling two loans, it's relatively straightforward to just say, well, I'll build it for 72 periods and then I'll delete the last 24 rows. You could build it in a timing flexible way. Under exam conditions, you probably wouldn't do that. As you know, or you may know, my goal is to keep the whole video within the 40 minutes allocated for the question. So if I have time left at the end, then I may show you how to do a pure dynamic array option so that it will, the size of the model will flex up or down when you change this assumption. But it's a little convoluted to do that, so it's not going to be my first priority. So anyway, that's the period number. Then I'm going to have the regular payment date, and that is just the same date of the month. So here we're going to say e-date from the drawdown date by these. Is that right? Do I need to say plus? Yes, I do. Okay. So there's a little weird thing with some of the date functions in particular that it occurs with some others as well, that if you give it an array argument, it doesn't like that, but if you give it plus the array, it forces it to convert the range reference into an array of values, and then it's happy to work with that. Still haven't entirely figured out why that is, but anyway. So with e-date, it basically takes you, n months forward. So in this case, 1, then 2, then 3, then 4. So you always end up on the 19th. The nice thing when we get to the second question is that e-date naturally incorporates this bit here. So if I drop in the 30th, when I get to February, where the heck is it? There it is. It'll automatically, it won't try to go to the 30th of February, it'll go to the 29th. And, the next year when February has 28 days, wherever it's gone, there it is. So it automatically incorporates that logic of, don't try to go to a day in the month that's further along than exists. So then actual payment date. So for question one, we just need to look forward to the next business day. So the first question you might reasonably ask is, how far forward might I need to look? Now, with this particular list of holidays, you can see some of them are just a few days apart, and if you check on these, you'll see some of these are actually like a Friday and a Monday around a weekend. So you could have up to 4 non-business days in a row. So you might, in other words, need to look as many as 4 days forward. I'm going to be a little more, just because you want to build a model that'll work if the list of holidays changes. So just to be extra safe, I'm going to look up to 2 weeks forward and up to 2 weeks back, just to be careful. So I'm going to start with let. I'm going to say start date is here, and then I'm going to say dates is start plus sequence. So I want 29 different dates starting from 14 days before, ending up 14 days after. Sorry, that's that, and then let's just output dates for now, and again we'll carry this format over. So now you see we have from the 5th of February, 19th of February is our date in the middle, up to the 5th of March. And then we're going to basically filter these out in terms of what makes these valid dates or not. So first I'm going to say not weekend. Now there's a couple of different ways you can do this depending on what you know about date values in Excel. One is you can use the weekday function. So weekday of dates. The challenge with this one is I always have to kind of squint at these to remember, what's the default and whatever. But okay, so here, for example, if I do Mondays 1 through Sunday 7, then not weekend is equivalent to that is less than or equal to 5, or let's just say less than 5.5 to allow for floating point errors. That's one way to do it. Or the other way you can do not weekend is you can say text of dates, and the text we want to do is give us the day as a 3-letter thing. This is my kind of preferred way because I find it more intuitive, and I always have to check when I use weekday, is it from Sunday to Saturday, or is it from Monday to Sunday, or which number does it, or whatever. But obviously if your settings are not in English, then this won't work exactly for you. But in English, we can just say weekend days are days that start with an S. So if you convert the date into a 3-letter text, and then take the left of that, meaning the first character. If that's not S, then you're not a weekend. If it is S, then you're a weekend. So that's not weekend, 2 different ways. Next is not holiday, and that's going to be, we want to say that date is not a match if I look for it in here. So that could be something like countifs. Whoops, sorry. Countifs. I should really just have given this that list of holidays a name, so I'm just going to refer to it as halls, and then I'll go back and name it in a second. Count if halls dates equals 0. So if the count of the number of times this date occurs in holiday is 0, that means that it is not a holiday. And then let's just output them all for a second. So we can say dates, not weekend, not holiday. And the not holiday is going to throw an error because I have to go and give this a name. So let's give this the name hulls. And now we can see, there's no holidays in this range. Let's just find where are we near a holiday. I guess 25th of October. So let's take this down here to October. And we should, there we go. Yep, so we got the 25th of October. Sorry, I just need to copy the formatting more. So the 25th of October fails, and these weekend days fail as well. That's strange if the 25th of October is a holiday, or sorry, is a weekend day and also a holiday. Let's just come down here, and what day name is that? It is a Sunday. That's weird. Okay, fine, it's what it is. So anyway, what we're interested in doing is basically filtering these dates. Say valid dates is filter dates where it's not a weekend and it's not a holiday, and we can just multiply those two together. I've mentioned this a bunch of times before. If you put truth and falses into arithmetic, like addition and multiplication, true is treated as 1, false is treated as 0. So if both of these are true, the product is 1, and that row stays in. If either of them is false, the product is 0, and that row gets filtered out. So then do that and return valid dates, and we can see instead of the 29 that we started with, we end up with 21. And then I guess the other condition that we want to throw in is same month. So we'll say same month is month of start equals month of dates. And then we want to throw that one in as well, so we'll just multiply that again, same month. And now you see our list of valid dates ends at the 30th of October, where before there was one in November. Okay, so now these are all the valid dates in the range, and now we want to sort by which ones are useful. So I'm going to define one more variable, which is before, and that's going to be valid dates is less than start, because basically the order of priority is, any date ahead that is valid, meaning that it's within the same month and a business day, is preferred. So we're going to sort by, so we're going to sort on whether it is before. So then we can output sort by dates, sorry, not dates, valid dates now, because that's the one that I've already filtered, where before, we'll just sort by before and see what direction that goes in. So yes, that's giving me everything after, and then it's giving me all the ones before. Now the last little twist is the ones before are sorted in the wrong direction. So if it's before, I want the latest one from before. So I'm going to sort by before, and then we'll sort by how far away they are from the target date. So abs of valid dates minus start. And we want that one to be ascending, descending, ascending. Yes. So that basically gives us, these are all the valid dates in the 2-week period around the 19th of October, sorted by first whether they are after it, and then by how far away from it they are. And then among these dates, the one that we want is just the first one of these. So we'll just say index on all of that mess 1. And that's the actual payment date. A lot of steps involved, but with let, the logic is actually, I'm just going to be slightly pedantic and lay my let out a little more neatly. But you can see, it's kind of made up of a lot of simple to understand pieces, even though there's a lot of moving parts here. So there we go. So that's our actual payment date. And we'll copy that all the way down. Whew, so now that was a lot. So now we need to figure out the days in each period. So for the first one, that's just going to be the actual payment date minus the drawdown date, and for everyone after that, it's going to be payment date minus the previous one. And I always like to color a formula that's different from the rest of the block differently, so I'm not tempted to copy down from there. And then we're going to want opening, interest, payment, closing. So the opening balance is going to be this. And again, sorry, let's make it red because that's a different formula. And the interest is going to be opening balance times the number of days over 365 times the interest rate. Sorry, I'm not going to lock the column on that one because that'll make it easier to copy this over to a new model. And then the payment, I'm just going to put in minus 5,000 as a placeholder for now, because we'll need to solve for that payment in a minute. And then we'll sum these. What? Oh, sorry, 246. For some reason I was reading 256. I was like, why did the balance go up? That makes no sense. But okay. So then we copy this down, 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 and then this is where it was recommending use goal seek. So in other words, what size of payment repeated every period would get you to this. So the way we're going to do that is we just need to have one cell that everything depends on. So we'll link everything to that first cell, and then we'll Alt-TG so we want the loan to balance out to 0 by changing this cell here. And we get a payment of 4,050, and that clears the loan. Okay, so now we should be mostly able to just kind of reproduce all of this for the second loan. So let's just grab these assumptions here. And let's clear out this piece here. So we just have the holidays there. All right, so let's see what needs to change. The 48 is good. All these formulas got to get rid of. And let's see, is everything pointing where it should be? That's pointing up there, that's pointing up there, that's pointing up there, that's pointing up there, it's pointing up there, it's pointing up there. Yes, that all looks good. So then we just need to goal seek this to 0 by changing the payment again. And we get a payment of 2,395, and that clears the loan after 48 months. All right, so let's go, I'm just going to put in a new tab for the questions and answers, and we'll go see if we got the questions right. I think there's just 8 questions in this one, 4 for the first loan and 4 for the second loan. So I guess we'll put in link and choice. So let's get the questions. Okay, question 1. For loan 1, how many of the regular payments are not on business days? Okay, so kind of a interim step that I glazed right over there, but I guess, wait, I can just use different, how many of these are different from those as a proxy for that. So I'm just going to say sum minus minus this is different from this. I don't like to add interim columns in my model that I'm not actually using, but that's just me. So that's C24. Okay, for loan 1, total interest paid over the life of the loan is closest to 41589. Closest to 41590, so D. For loan 1, the monthly payment amount ends in what number of cents? Okay, so let's get precise. and that is 85. So for that, I will say equals this. So I'm going to say let the payment be the absolute value of this. We can just say minus. Don't need to say absolute value, whatever, because I know it's negative. Then cents can be payment minus int payment. I guess times 100, and then it can be round cents 0. 85. So that's A. Question 4. For loan 1, after how many payments does the outstanding loan balance first drop below 40% of the original drawdown value? So here, what we can do is we can look up the original loan value times 40% in here. Actually, sorry, no, I don't want to look up. I want to know after how many payments. So say countifs. How many of these are greater than or equal to this times 40%? And then I just need to figure out my off by 1. So just quickly check here, 45 payments that are less than it, so it's the 46th payment that takes it below. So yeah, it should be that plus 1. So that's C. All right, now loan 2. How many interest periods have exactly 31 days? Okay. Oh, I did put days in there actually, so that's easy. Countifs. Days. 31. 13. That's B. Loan 2, the monthly payment amount is, just come over here, and it's 2394.98. So that's B. Question 7. For loan 2, the loan balance immediately after the 12th payment on the 30th of June is what? Just go index this 12. 77566.34. That's B. And last question. So I guess that means I got it right. What proportion of total payments made over the lifetime are interest payments rounded to the nearest percent? So that can just be the sum of interest over the sum of total payments minus 13%, and that's A. So let's just quickly check out that right. CDAC BBBA. CDAC BBBA. Okay, cool. So just one thing I kind of thought about, didn't think about as I was doing it, but thought about it as I was pulling it up there. A lot of people will kind of model, well, two things. One is a lot of people will model this horizontally, which I just am indulging my old habits by going back to vertical. I actually think it makes much more sense. But I know that a lot of financial modeling purists hate it when I do things vertically, so sorry about that. But second thing is, you know, I always found it more intuitive to put, you know, to put the interest in here as though it's adding to the principal, and then subtract off the principal and interest payment, especially when you're modeling, you know, a mortgage style payment where the payment is the same every month. You know, with this logic, you can see that the payment is the same every month. Whereas the way other people will sometimes do it is, you know, opening, principal payment, closing, and then calculate interest outside that. There's nothing wrong with either. This one, it kind of flexes a little bit more naturally if you have a pick toggle. In other words, that your interest might sometimes be payment in kind, so that the interest just adds to the principal, because you're calculating your interest within here. But on the other hand, if your loan has equal principal payments, then this payment will be different in every period, and it won't be obvious that that's the case. So I don't know, I'm a fan of a certain amount of flexibility, but again, if you're modeling a portfolio of loans, it's probably more important to be consistent across the portfolio, but is what it is. Anyway, that's that. I have some time to spare on my 40-minute target, so I'm going to keep going, but if you just wanted to know how to solve the question, you're very welcome to stop there. But let's go look at a couple of rabbits we can pull out of hats. First, for the actual payment date. So we did this from first principles here, and it's all, you know, it all makes sense, but it's quite convoluted. There is a function in Excel called WORKDAY, There's also Workday Intel and Workday International, which gives you even more flexibility for certain odd use cases. But the idea is, from a start date, you go forward or backward a certain number of business days, meaning not weekends, and you can supply it with a list of holidays. So let's just find one here. So here, for example, the 19th gets pushed to the 20th. So if I say Workday from here, one day forward with this list of holidays, it gets me to the 20th of April. But let's see, let me just find one where there's a bigger gap. So, oh, there's actually not any big gaps forward. There's only big gaps backward. But okay, fine. Let's go to one with a gap backward. So here, for example, we could say Workday from the regular payment date, go one working day backward with this list of holidays, and it'll get you to that same 28th of April. So how would you use that here? Well, the logic is pretty simple. You could say, so I'll leave the original calculation in there in case people want to look at that, but I'll just put in actual PD alt here. And the alternative would be, basically, if you want to find today, if today is a working day, or otherwise the next working day forward, I kind of hoped when I played around with this that Workday from here 0 would jump to the next working day if that day wasn't a working day, but it doesn't. But what you can do is basically just subtract 1 from the working day and then go 1 working day forward. And then if the day you started from is a working day, you'll go back 1 day, forward 1 day, and stay where you started. Otherwise, it'll be the next working day. So here's what I'm going to do. I'm going to say let next working day be that. So go back 1 day and then forward to the next working day. Then previous working day is going to be Workday. Oops, sorry, not word. Workday from C10 minus 1, again using the list of holidays. And then we're going to say if month of next workday is different from month of C10, then previous workday, otherwise next workday. And I'll just do a quick check, and that equals, that should be true, and it is. And we'll just carry it over here and see if it works on the one where we also have to go backward. So that equals that, and it's always true. Okay, so that's one thing you could do that kind of simplifies versus the kind of quite complicated logic here. You can do it very, very easily with that. Second thing is, let's sort out this this goal seek issue, because that's ugly. Like I said, if you wanted to model a portfolio of 100 of these, or if you want to, just be able to change the, okay, now it's 300,000, but I forgot to hit goal seek, and down here actually the loan is not balancing out to 0. That's not cool. So this is actually like a big enough concept to be worth spending a couple of minutes on. So let me flip over to the slide I prepared earlier, so to speak. So let's say you've got a mortgage for whatever, $250,000 for 20 years, 5%, and just for simplicity, let's say we're making one payment a year. So you start off with $250,000. A year later, it has grown with the interest to this amount, and then you make a payment to get it down to here, and then another year later, the remainder of the principal grows with interest, and then you pay it off a certain amount, and you carry on like that until you pay off the whole thing. And so what you can see, as you would expect, is that these payment amounts are staying the same over time because it's a mortgage style payment. B, you can see that the sum of the payment amounts is obviously bigger than the mortgage, because what you can see is that they all overlap, a lot at the start and then just a little at the end, but they all overlap. And even if you just kind of ignore the overlaps and run them one after the other, it still gets out to kind of here higher than the mortgage amount. Second thing you can see when you look at it this way is, if you look at this payment here, you can say, well, most of that is kind of covering off the increased amount from interest, and then just a small amount of it is paying principal. And if you look at a typical mortgage schedule, you'll see, principal payment, interest payment. And what you'll see is that over time, it starts off with the interest payment being almost everything. And then it ends up, down at the end with like almost no interest left to pay, and you just pay off the last chunk of principal. And so it seems like you're having a much bigger impact on the principal over time with that payment. But if you think about it a different way, what percentage of the original balance as inflated by interest in between are you paying off with each payment? Well, actually here, you're paying off a much bigger percentage, because here any principal balance that's left here has gone, has been increased by 5% interest for 20 years. So in other words, it's 1.05 to the power of 20. It's 2.65 times bigger than it was when it started. So that the actual proportion of the original principal as kind of grown by interest over time that pays off is much smaller. So if you basically kind of compress each one of them according to the proportion of the original principal they paid off, so this is kind of sized to match that original 250,000. The first payment is by far the biggest one, the last payment is the smallest one. But how do you think about how this compression works? Well, basically say a payment here, so the first payment is after the balance has gone up by 5%. In other words, the first payment is having the effect of 1 over 1.05 payments. So it's like the amount of the original principal as grown over time that it takes away is about 95%. It's slightly less because, basically plus 5% and minus 5%, if you multiply them, don't cancel each other out. But if that doesn't sound familiar to you, then don't worry about it. And then the next one will do, 91%, 86%, 82%, 78%, 75%, and so on. So if you think about, you can then do that for 20 years, 1 over 1.05 to the power of sequence 20. So you get 95%, 91%. So how many payments did you make in total? Or sorry, how many discounted payments did you make in total? Well, the answer in this case is you made 12.46 discounted payments. And if you look, you see, take the original balance, divide by that 12.46, that gives you the exact same payment as the PMT function. So you're basically saying, the first payment is worth, 95 cents in the dollar on a present value basis. The second payment is worth 91 cents in the dollar, 86 cents, and so on down. But the cool thing about this method is that you can use this first principles method when the very, very strict assumptions of the PMT function don't apply. In other words, you can use it if the interest rate changes over time. You can use it if the size of the periods changes, as in this case, or both of those things are true. Basically, all you need to be able to figure out is what is the discounting rate for the space between two periods and what's the cumulative discounting rate. So let's look at that in practice. We'll say disc rate. That could be, so you just basically think about how much interest is hitting, and you just want 1 over 1 plus the interest that's hitting. So that's that, and then here, basically for each subsequent period, you're going to start with the previous discounting rate and then divide by the interest that's happening. And then the sum of these, this is basically telling you how many cents in the dollar of the first, second, third, fourth, up to 72nd payment is going to hit. So if I sum those up, you see of the 72 payments, the original loan balance is going to match 61.73 of those payments. And so, hopefully I got the math right first time, if I take this and divide it by this, I should get that same 4,050. And look, you even get it, the 85 cents. So now, I'll clear out my two things that are just hanging around at the top, but then you can just say this is going to be minus the loan amount over the sum of the discounting rates for each of those periods. So that's, and now that I've done that, if I basically take this and drop it in here and then just kill those, kill the extra rows, then what I should end up with is an exact copy of what I have over here. And you can see it kind of matches the same profile on the way down. So that's just a simple check the logic is now flexing. Last thing, I've got 5 minutes left. I'm not even sure I'll have time to do this, but if I run out of time in my 40 minutes, I'll stick it in the file I upload anyway. But let's try the, I'll just call it, so I'll make another copy of the tab and I'll call it Model DA for dynamic array. And let's see if I can make this whole thing hum with a dynamic array. So first I'm going to use the simpler payment date formula. And now I'm just going to put hash on here, make all of these references reference the whole period. And I think that's going to, well, first it's going to spill because I need to clear out all the ones below. And then it's going to behave. And I'll put the same thing over here. And yeah, that's what I thought. That's what I remembered from when I looked at this earlier, is it doesn't like the previous Workday. So it's the same thing as before, that you just need to multiply this by 1 or put a plus in front of it or something like that, and then it will behave. Then my days, this is more complicated because any of these ones where I have a different formula in the first row are going to get slightly complicated. But the way I'm going to do this is I'm going to say these dates minus, so basically from the first one I want to subtract the drawdown date, and then from each other one I want to subtract the previous one. So what I'm going to do is vstack this on top of this where I drop the last one. So drop that, minus 1 to drop the last row. And that will fill down my day calcs. Format back. Now for the discounting rate, I'm going to have to do a scan. So we're going to say scan, starting from 1, operating on the number of days. And the lambda is going to be AV, or let's do it DR for disk rate and days. And it's going to be previous discounting rate divided by 1 plus the days over 365 times the interest rate. Close the lambda, close the scan. Again, that spills, but get rid of all the rest, and that seems to be behaving. Now, this is the most complicated piece. I've seen people, build dynamic array models where they say, well, you can make a dynamic model of a mortgage that will flex up or down when you change the duration, but only because you can basically calculate each period independently of all the others by using, PPMT and IPMT. For this, there is an interdependency that you can't get away from. So the only way that I know of that you can build it is with reduce. So I am going to reduce starting from an initial value. So I'm basically going to build one formula for all these 4 columns. So my starting value is going to be H stack 0, 0, 0, and then that. So in other words, I'm going to start with something saying, in the 0th period, I have a closing balance of that amount and no opening, no interest, no payment. And then my array is going to be my number of days again, because I'll need that for the interest calculation. And then lambda of, I'll call it cumulative and days. And so what's the function going to look like? Well, first thing is I'm going to build it up. So first thing I'm going to do is stack the previous cumulative on top of something, and then I'm going to have to H stack 4 things together to make the bottom row. So let's actually do a let before the H stack. So I want the previous balance is going to be the bottom right corner of the kind of block I've built up so far. So we'll take cumul minus 1, minus 1. The interest is going to be days times interest rate. I don't need to lock it, actually, I'm not copying it anywhere. Times the previous balance divided by 365. Definitely did not write that the most elegant way, but I'm just going to move on. So then we're going to H stack previous balance, interest. Oh yeah, now I need to get the payment from somewhere, which I guess I can just do now. So it's going to be minus this opening balance over the sum of this array, and the closing is just going to be the sum of all of these. So previous balance plus interest minus that. So that closes the H stack, that closes the let, closes the V stack, that closes the lambda, that closes the reduce. And let's see if that worked. Oh yeah, sorry, then I need to drop the first row. Okay, I'm not quite going to finish the video in 40 minutes, but I'm going to be pretty close. I trust you will indulge me. So drop the first row of that, and then we can, let's do a quick check. That looks awfully similar to this, so yeah, I think we're golden. The other quick check we can do is, if I now drop this in here, that you can see it immediately resizes to be only 48 periods, everything else disappears, and the amounts all match up. So that's pretty darn cool, though I say so myself. And then I can just take this whole thing, copy it, put it over here, and that works. All right, that's all I got time for today. Thanks for watching. I'll be back with the other 2 questions from this round later in the week. Bye-bye.